Some of us have experienced this before: going to the bar with friends, chugging a few glasses of beer, getting a bit drunk, then finally realizing that we have to drive ourselves home. But how are we supposed to know how much alcohol we've had for the night? There are three ways to measure alcohol intake. First is by getting the blood alcohol concentration through injection. It gives accurate results, but is painful because it is an invasive technique. Second is through the breathalyzer, which measures alcohol content through the breath. It is non-invasive, but it provides less accurate results, as vapors in the air might tamper with the sensor. The third technique is through transdermal alcohol concentration devices, which measure alcohol intake from the sweat. It is non-invasive and accurate, but the problem is it gives a delayed response of about zero point 0.5 to 2 hours. To improve the current methods for alcohol detection, Joseph Wang's group from University of California, San Diego developed a temporary tattoo which can monitor alcohol intake accurately, non-painfully, and in real time through iontophoresis and Bluetooth. The temporary tattoos work in a place, detect, dispose framework. The actual device has two parts. One is a temporary tattoo that clings to the skin, and the other part is a flexible electronic board that is smaller than a stick of gum and attaches magnetically to the tattoo. The wearable prototype enables the transdermal delivery of the pilocarpine drug to induce sweat via iontophoresis. Iontophoresis is the introduction of ionic drugs into the body through the skin by applying a local electric current. The sweat comes up to the skin surface, and an electrochemical sensor made of the alcohol oxidase enzyme and the Prussian blue electrode transducer measures alcohol concentration in the sweat. As the concentration of alcohol increases, output current also increases. This sensing operation is controlled by a 1 cm electronic board, which will then transfer the results via Bluetooth to the wearer's device. Great features of the temporary tattoo include real-time detection of alcohol in a span of around 8 minutes only, its cost-effectiveness, wearability, non-invasiveness, and selectivity to ethanol. In addition, the size of the tattoo makes it less intimidating to wear, thus reducing the stigma that surrounds people who wear bulky alcohol monitoring devices. A total of 9 healthy volunteers were recruited for on-body evaluation of the developed sensor before and after consumption of alcoholic beverages. The group's findings show that the tattoos were actually selective to ethanol from the generated sweat. There is also a good correlation between the volunteers' sweat ethanol level and their blood alcohol concentration, as indicated by the linear increase with the current response versus blood alcohol concentration plot. In addition, the wirelessly transmitted current response showed a clear difference in the signals before and after consumption of the alcoholic beverage, demonstrating that the temporary tattoos could be accurate in transmitting data on alcohol intake. If commercialized, possible markets for the tattoos are the law enforcement agencies, service industry personnel, individuals who want to monitor their alcohol intake, and health professionals. Alcohol monitoring is not a new innovation topic. There are several existing patents for alcohol monitoring, and among them, the most famous ones are the devices developed by Scram. Scram is a track and trace device that individuals in the US, under house arrest or on parole, are required to wear. As a radio frequency transmitter unit, it measures alcohol consumption through sweat, then sends a signal to a fixed location receiving unit in the offender's residence. The residence unit uses either landline or a cellular network to relay the information to a service computer center. In the future, all biomedical sensor applications may soon be integrated into a single tattoo. Wang's group has made similar printable tattoo sensors for transdermal glucose and lactate monitoring. Longer-lasting tattoos could also be developed in order to lessen waste. Finally, a more personalized tattoo, which is sensitive to differences in skin permeability, could be considered. The tattoo biosensors could serve as cheaper and more accurate alternatives to breathalyzers, which cost almost 65,500 pesos each in the Philippines.